Insya Allah penginten ku abdi di hayam pada diurus diendaugkeun kaum nami-nami penghasilan abdi
untuk telur kon nelor lah. Nah yang lelakinya untuk dijual.
Ya rasanya ya enak lah dipai mau wong dipai jangan usaha menang modal usaha terus pengen emang belajar bari.
Semenjak dikasih kambing burka dari Puslit Bangnak 20 ekor, alhamdulillah sekarang sudah menjadi 42 ekor. Dan terima kasih kepada Puslit Bangnak
mendapatkan bantuan sejumlah IT 1060 BOD. Dulu masih baru menetas, sekarang sudah produksi mendapat 345 butir per hari.
Semenjak ada bantuan dari dinas mesin untuk penggilingan pelepah sawit, nah itu sangat membantu.
Selama bertahun-tahun lamanya, Puslit Bangnak mengkokohkan diri sebagai riset dan pengembangan peternakan dan kesehatan hewan terkemuka dengan penghargaan yang didapat. Kami peduli untuk selalu memberikan informasi dan manfaat bagi peternak sebagai bentuk tanggung jawab kami. Selalu bergerak menatap ke depan, berupaya untuk terus berkarya, mengutamakan kebutuhan peternak dan mewujudkan kemudahan informasi masyarakat. Pusat Penelitian dan Pengembangan Peternakan menuju inovasi tiada henti.
Persoalannya memang Prof ada dua, pertumbuhannya yang sangat memang terbatas tapi punya daya tahan. Yang kedua memang dagingnya keras. Kita buktikan malam ini Pak Gub.
Maka pada malam hari ini kami mencoba mempersembahkan kehadapan Bapak Ibu sekalian spesial Bali Beef daging asli sapi Indonesia yang diharapkan dapat mendunia dan dapat menjadi kebanggaan bangsa Indonesia. Dengan berbagai metodologi yang kita terapkan dalam beberapa tahun terakhir ini, insya Allah Pak Menteri bisa membuktikan nanti dagingnya menjadi lebih empuk.
Untuk pertama kali mendapatkan sapi Bali dengan daging yang selembut ini, saya rasa sudah seperti sapi-sapi yang ada dari impor atau dari luar. Saya tertarik dengan spesial Bali Beef ini karena saya menangkap ada aroma khas dan ini mungkin yang kelebihan dengan yang lain. Oleh karena itu saya yakin daging ini, daging Indonesia, punya khas yang Indonesia. Saya yakin ini akan menjadi sebuah prospek bagi kita semua ke depan.
Justru yang kita jual itu keunikannya, nilai nutrisinya, tapi yang kita perlu promosikan itu adalah sapi Bali sebagai daging yang rendah lemak.
Jadi kami menguji banyak sekali formula pakan dan kami menemukan bahwa ada dua tanaman lokal yang ada di daerah kita. Yang pertama adalah daun turi yang ada di banyak di Lombok Selatan dan yang kedua adalah lamtoro.
Perbedaan daging sapi Bali yang kita treatment dengan lamtoro ini, satu adalah kampukan dan kedua memang ada rasa yang spesifik yang tidak ada di daging-daging lain. Ada taste yang berbeda di dalamnya. Saya bisa merasakan perbedaannya.
Akan ada pemain besar yang akan mengembangkan sapi ini sehingga bukan mustahil dalam waktu tidak lama lagi sapi beef Bali yang rasanya tidak kalah dengan sapi-sapi dari Jepang akan menjadi tuan rumah di daerahnya sendiri.
Kita akan buktikan bahwa daging kita ini kalau kita budidayakan akan mampu memberi nilai tambah yang tinggi, itu satu. Yang kedua, dagingnya juga secara khusus bisa dikatakan tidak kalah dengan daging lain. Ya, saya kira alasan untuk impor untuk kita juga sangat tidak masuk akal gitu. Believe your dream and your dream become true. Believe it, make it happen.
Menteri Pertanian Syahrul Yassin Limpo menyerahkan 20.000 DOL chicken atau DOC ayam Kampung Unggul Balitbangtan kepada Menteri Koordinator Perekonomian Erlangga Hartarto. Penyerahan dilakukan secara simbolis saat keduanya menghadiri acara ekspos hasil inovasi Badan Penelitian dan Pengembangan Pertanian di Balai Penelitian Ternak Ciawi Bogor, Kamis 6 Mei 2021. Di kesempatan ini, Erlangga juga memberikan nama untuk galur ayam Kampung Unggul Balitbangtan atau KUB ini.
Jadi saya kasih nama Janaka. Soalnya ini ada Kunti, Ibu Kunti. Janaka itu nama lain dari Arjuna. Satu telur tiap 2 hari. Dan ini bisa juga menjadi pedaging. Dan dengan demikian ini tentunya baik untuk dikembangkan, punya nilai ekonomi yang tinggi.
Menteri Syahrul menilai kehadiran Janaka merupakan salah satu bukti bahwa akselerasi ekonomi di bidang pertanian cukup tinggi. Untuk itu pihaknya siap dalam mengembangkan serta menyebarluaskannya ke berbagai daerah di Indonesia.
Pak Menko tadi memerintahkan pada kami di jajaran Kementerian Pertanian agar ini bisa dikembangkan lebih kuat, bisa disebar ke seluruh pelosok yang ada. Saya kira di Idul Fitri ini, Ramadan ini, tanda-tanda akselerasi ekonomi di bidang pertanian cukup tinggi, sejalan juga dengan hasil triwulan 1 PDB nasional kita, kontribusi pertanian naik 2,9.
Janaka sendiri merupakan galur ayam KUB 2 yang telah memiliki perbaikan performa dari ayam KUB 1 melalui seleksi genetik. Performa yang ditingkatkan antara lain produksi telur, sifat mengeram, dan warna sheng atau kaki.
Janaka ini kelebihannya adalah dia mempunyai produksi telur 200 butir per ekor induk per tahun atau rataan hendainya itu 60%. Tujuan dari pembentukan galur ini adalah sebagai galur unggul female lain ya, galur betina untuk menghasilkan DOC ayam kampung unggul ayam lokal potong. Jadi bisa panen pada umur, kalau yang KUB 1 dulu umur 70 hari, bisa berkurang menjadi sekitar 55 atau 60 hari. Jadi keunggulannya itu. Kemudian sifat mengeram dari indukannya masih ada sekitar 5%.
Selain ayam, pada kesempatan ini Menko Erlangga juga memberi nama untuk sapi Belgian Blue Cross. Sapi yang kemudian diberi nama Pari Kesit ini merupakan hasil persilangan antara Belgian Blue dengan sapi Friesian Holstein yang memiliki rata-rata berat potong sebesar 533 kg. Hingga saat ini, sapi Belgian Blue Cross yang telah lahir sebanyak 22 ekor. Salah satunya berumur 3 bulan 2 minggu yang memiliki bobot ternak 110 kg. Dari Ciawi Bogor, Andika Bakti, Indra Fauzi mengabarkan.
Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, peace be upon you. Good morning, ladies and gentlemen, and best wishes for all of us. The Honorable Director of Indonesian Center for Animal Research and Development, Dr. Agus Susanto, Dean of Faculty of Animal Science, University of Mataram, Dr. Maskur. All Director of Research Center under Indonesian Agency for Agricultural Research and Development, invited speakers, and all participants. Ladies and gentlemen, thank you for your coming on second day of the 4th International Seminar on Livestock Production and Veterinary Technology. Before we begin, I would like to introduce the agendas today, which is 1. Plenary Session 2, 2. Parallel Session 2, 3. Closing ceremony, such as summary report by Chairman of the Committee, Dr. Endang Romjali, following by announcement of best presenters by Co-Chairman Professor Dahlanuddin, PhD. And the last, closing ceremony from Dean of Faculty of Animal Science, University of Mataram. Ladies and gentlemen, today we will hold a discussion with 4 keynote speakers. The second plenary session will be moderated by Professor Yusuf Sutaryono from Faculty of Animal Science, University of Mataram. Professor Yusuf expertise in forage and livestock production system, also livestock bionomica and ecosystem. He active as head of Consortium of Large Ruminant Research, University of Mataram. Without further ado, now please help me welcome our moderator for Professor Yusuf. The time is yours.
Thank you very much, Desi. Good morning, all invited speakers, all presenters and participants. Welcome to the second day of the seminar. My name is Yusuf Sutaryono. I from the Faculty of Animal Science, University of Mataram. And this in particular session, I will be assisted by Dr. Madi Sriasi as a secretary of the session. For this plenary session today, we will have 4 invited speakers. Those will deliver their presentation. The first is Insinyur Yudi Guntara Nur, IPU, and Dr. Rahmat Hidayat, IPM from Indonesian Goat and Sheep Farmer Association. The second speaker is Professor Stephen Morris from Massey University, New Zealand. The third is Professor Dennis Poppy from the University of Queensland, Australia. And the fourth speaker is Professor Dr. Jian Lin Han from the Chinese Academy of Agricultural Sciences, China. For all the speakers, I want to remind that the duration of the presentation is 20 minutes. And at the end of the session, there will be time for discussion for 30 minutes. For those participants who would like to ask a question, please write down your question in the chat room and we will compile it. Ladies and gentlemen, now we will proceed for the first speaker, which is Insinyur Yudi Guntara Nur and Dr. Rahmat Hidayat. The title of the presentation is The Development of Dorper Sheep in Indonesia. For this session, the presentation will be delivered by Dr. Rahmat Hidayat. Let me allow me to read the curriculum vitae of Dr. Rahmat Hidayat. Dr. Rahmat Hidayat got his doctoral degree from Bogor Agricultural Institute, Indonesia. And currently, he is the Dean of the Faculty of Animal Husbandry, Pajajaran University, Bandung, Indonesia. He is also a research and development staff at the Indonesian Goat and Sheep Farmer Association. Dr. Rahmat Hidayat involved in 26 trainings and seminars and published 49 publications. I would like to invite Dr. Rahmat Hidayat to present his presentation. Dr. Rahmat Hidayat, the time is yours. Please.
Okay. Thank you, moderator. I am here to replace Mr. Yudi Guntara as the head of Goat and Sheep Farmer Association in Indonesia. Let's share screen. Okay. Here I will explain about Dorper sheep development in Indonesia. The population of sheep in Indonesia has not been able to meet the demand of the domestic and international market, which continue to increase every year. There is a significant gap between the upstream sector in sheep farming and then downstream sector in industry. This has resulted in stagnation of supply to meet the market. On the other hand, sheep productivity is still relatively low due to traditional farming. Here, I saw the general condition of goat and sheep farming in Indonesia. 93% farmer of sheep and goat is smallholder scale, between 3 until 10 heads of animal. then the productivity is still low. The population of sheep in Indonesia about 7 million point 33 million head. There is inefficiency in life stage model, and the local sheep in Indonesia have medium type, and the feeding model is cut and carry, and all of the activity of the farmers not integrated with the market system. It's connected to supply chains. Here, HPDKI collaboration with the farmer to create inclusive closed loop system. We develop financial engineering innovation from the financial side and transaction patterns that are adaptive to the production pattern of each cultivation system. Cultivation scheme in the People Business Credit Financial Inclusion Program, and opening alternative market access. Export as an alternative market from farmer to sell through regulatory change 2018. And second step, third step is supply chain production to engineering. Conduct livestock corporation to consolidate farmer at the upstream level so that they are integrated with the downstream market system. Cluster model, sheep, goat, and corporation. And the fourth step is application of technology and breed introduction. Introduction to off-farming technology, breeds of Dorper sheep to increase added value and production capability to produce commercial stock, genetic combination Dorper cross Garut. And this inclusive closed system will be duplication in some region such as North Sumatra, Banten, Yogyakarta, Central Java, and East of Java. Here, the scheme of the closed loop system of the cluster. We introduce, HPDKI introduce new genetic of sheep as a Dorper sheep, farmer consolidation tool, and this is to productive small farmer. The financial inclusion core, we collaborate with BJB. The BJB financing of supply concentrate and sheep. HPDKI coordinate with some smallholder. There are two kinds of farming: smallholder fattening cluster and smallholder breeding cluster. And the agroinvestama as a off-taker in industry. All of the product of the smallholder collected to the off-taker is agroinvestama. And the agroinvestama incubating farmer as off-taker lamb, and then supply concentrate needed, facilities financial inclusion with bank providing study. And smallholder, consolidated the farmer start crossbreed shelter cage, insurance, assistance, and harvest purchase guarantee. All of the animal is insurance. PDKI improving and connecting market, the production from small farmer collecting in PT Agro Investama, and is improving the connecting and market. Connecting small farmer production to industrial market, standard quality RAM and etc. Modern market, we create modern market and restaurant. Innovation digital online urban to Singapore and Malaysia. Here we trained the smallholder farmer. In some farmer join in this exercise. Dorper Indonesia. Dorper is a breed of composite breed from South Africa as a result of crossing the blackhead Persian sheep with Dorset sheep, Dorset horse. Dorper sheep was first developed in Indonesia by PT Agro Investama Farm in Garut on 15 February 2018. Imported from Australia. The main reason the Dorper sheep breed was developed in Indonesia is because it has good meat production properties to produce commercially slaughtered sheep and are bred with local Garut sheep. Currently, Dorper sheep has been recognized and released as a family by the Indonesian government through Minister of Agriculture decree. Here the number of Minister of Agriculture date in February 25, 2021. Here the document I said as and date in 25 February 2021. Here the scheme of the breeding program of Dorper and Garut development in Indonesia. We have two program mating. First is mating program of Dorper cross Dorper. And the second is mating program for Garut and Garut sheep. And F1 of Dorper full blood as a genetic resources of milk. And F1 of Garut genetic resources of breeding. F1 of Dorper and F1 of Garut cross and F1 of cross of Garut and Dorper. All of the female of cross is slaughtered in restaurant in PT Agro Investama, and F1 male as a we cross the F1 of male to the local sheep, and the F2 between F1 cross and local, it is a commercial cross. And the commercial cross, we will spent to the domestic market and market export. All of the process we control from the feeding and breeding program. Purpose of mating, first mating, stock of pure genetic sources and local genetic conservation. Here is the Dorper full blood and Garut full blood. Is a conserving genetic local. Second mating, source of cross male with a good combination of meat and breeders genetics. And third mating, all of the animal is a commercial cross. They have 25 Dorper blood. Here industry cluster partnership smallholder of farmer. Here the performance of the Dorper sheep Indonesia. Litter size average is 1.18. Standard deviation is 0.38. And birth weight in one lamb is 3.5 kilogram. And for the twin is 2.94 kilogram. Winning weight in lamb in about 21.3 kilogram. And winning weight of twin lamb is 15.50 kilogram. Age of winning is 90 days. And pre-winning weight gain 3 months about 177.31 grams per day. Lambing interval is 245 days and pregnancy day is about 155 days. And conception rate failure 0.12%. And percentage of male is about 42.5% and percentage of female lamb about 57.50%. And lamb mortality until weaning about 13.04%. Comparison of pure breed Dorper and their average reproductive trait over 3 mating season or more from different sources. Lambing percentage lamb born for ewe joint, birth weight of lamb survival until weaning, number of mating, that the data is average mating system. Here the data in Elias et al. The average lambing lamb about 137, and we can see the references. Average across a study is 124% for average lambing born lamb percentage, and birth weight about 4.1 kilogram, and lamb survival until weaning about 87.5%, and pre-weaning weight gain about 243 grams per day per head. Here, the Dorper sheep body size, Dorper sheep in Indonesia. Age month 12, and age in 2 years about 28, and age 1 year in 1 years 11, and in 2 years is 28. Body weight.
Excuse me, ex-speakers, your time is 3 minutes more.
Okay, thank you. Here the data of the Dorper body size Dorper in Indonesia, and Dorper cross and Garut, but weight about 2.82 kilogram, and weighing weight about 15.92 kilogram, and winning age 90 days, and ram weight about 51 kilogram. Slaughter weight is 41 kilogram, and slaughter age is 257 days. Every daily gain fattening is 180 and 68 gram per head per day, and day of feeding about 160 days. And carcass percentage is very, very high. It's about 51.6%. It's a good quality of carcass. And as an information, the carcass percentage of local sheep about 45%. There are differences until 6% of carcass percentage. Here, the list of reference, diet breeding and result of breed comparison studies in terms of lamb growth rate are also included. And carcass lamb and else, here the cases of the disease, diarrhea about 25%, and convulsion 8%, premature 12%, and weak. There is a weak of the lamb is enough higher than other disease. There is no mastitis, bloat, and dystophia, and others. Thank you for the time, and the time back to the moderator. Thank you.
Thank you very much, Dr. Rahmat Hidayat, for your excellent presentation. Ladies and gentlemen, now we will proceed to the second speaker, which is Professor Stephen Morris from Massey University, New Zealand. The title of the presentation is Dairy Production in New Zealand, Production Systems, Marketing, and Role of Fonterra. Let me read the curriculum vitae of Professor Stephen Morris. Professor Stephen Morris graduated as a Doctor of Philosophy in Animal Science from Massey University, New Zealand. And currently, he is a professor in animal science in School of Agriculture and Environment, Massey University. Professor Stephen Morris is also an adjunct professor at the Faculty of Animal Science, University of Mataram. Professor Stephen Morris is also a senior advisor for multiple collaborative research programs with research group in New Zealand, South America, Europe, and China. He has experience in 165 beef cattle and sheep research projects over the last 39 years, and in totally already produced 197 journal articles, 17 book chapters, and involved in 165 conference proceeding papers. I would like to invite Professor Stephen Morris. Please, the time is yours.
Thank you and good morning. Can you hear me? Not sure that I am coming through in sound. Can someone indicate?
Yes, it is clear, Steve.
Okay, so I just want to acknowledge my co-author, Dr. Penny Back. She has helped me considerably with this presentation. So what I'm going to talk about is an overview of dairy production in New Zealand, describe the cooperative structure which links along the value chain farmers, processors and support industries, how this has added and created a viable dairy industry within New Zealand, and lastly give some thoughts about how Indonesia might consider a similar structure. So dairy production in New Zealand, 21 billion litres of milk or 1.9 billion kilograms of milk solids. 95% is exported to 150 different country markets. So we produce quite small by world standards, 3% of the world's milk, but big in terms of trade in dairy products. 35% of the world's trade in dairy products originate from New Zealand. It comes from 4.9 million dairy cows, about 11,000 herds or farmers. The average herd size is 440 cows, and the average production per cow is 385 kilograms of milk solids. We measure it by milk solids, with the average cow producing about 9% of its milk as milk solids. So what's happening with the industry? So this next slide, if you look at the grey line, number of herds has been declining. So from 1990, we had 15,000 farmers or herds with dairy cows, and now we just have 11,000. And the size of the herds have increased. So back in 1990, the average cow herd was 160 cows, and now it's risen to 440. So our numbers per herd going up, number of herds coming down. And when we measure production, we measure it per cow. So the average milk solids per cow, so this is up here, increased from 1992 to 93 from about 250 kilograms of milk solids per cow. It's gradually risen up over 360, and now it's at 385 kilograms of milk solids per cow. And land is a big constraint to our farmers. They have a limited amount of land, and so they have increased production. This is the green line, kilograms of milk solids per hectare, rising from just on 700 back in the early 1990s, and now the average production per hectare is 1,100 kilograms of milk solids. So more per hectare and more per cow over the last 30 years. And so we look at the cow makeup of the herd. Over half the herd, 49.1%, is what we call Holstein Jersey crossbreed. Some of you may have heard the term, they're called the Kiwi cow. That's a crossbreed between the Holstein Friesian and the Jersey. Pure Holstein is just under a third, or 32.7% of the cows. Jersey is 8.4%. And then there's a host of what we call others. Ayrshire, very small, at 0.05%. And then we have others here, which would be mainly crossbred between Holstein Friesian and Jersey. The big thing is that we have a large number of cows. You can see them in the paddock here, crossbred between Holstein Friesian and Jersey, which has been bred specifically for the New Zealand pasture-based system. And if you look at live weight of these cows, in the next slide, so what we originally had in New Zealand was Holstein Friesian. If you look at the dark green line here, they were big cows from 2-year-olds, just under 450, rising up to 550, through to 10 years of age. And then we had the Jersey, which were small cows at 2 years of age, 350 kgs, rising up to 440, 450, and then dropping off. So what our farmers did, and the Livestock Improvement Corporation, which I'll talk about later, crossed those two and produced this Kiwi cow crossbred, which is a moderate-sized cow producing a reasonable amount of milk solids per hectare and per cow. So we adapted those two breeds to produce a crossbred that fitted our conditions. Just this slide I thought was very interesting. Our footprint, carbon footprint, is very low compared to other countries, major milk producing countries in the world. In fact, we produce 0.77 grams of carbon dioxide equivalent per fat and protein corrected milk, FPCM. So there we are, 0.77 New Zealand. And if you just come down through Australia at 1.06, China at 1.68, mainly because we're outdoor grazing, very little concentrate feed used. The other countries similar to us is Uruguay. And so very low carbon footprint compared to the rest of the world. So we're a pasture-based system, and farmers aim to match stocking rate, that's how many cows per hectare, therefore the herd feed demand, as close as possible to pasture growing. Okay, so they're trying to match how much these cows eat each day, how much is growing each day on that hectare on that pasture. Supplementary feeds and crops are only used when pasture is less than cow individual herd cow demands or herd feed demands, and that usually occurs in dry summers. Summer down here is in January, February, or in cold winter months, say June, July, and sometimes August. So that is the only time when its supplementary feeds are used, and usually it is conserved forage, in other words, hay and silage. The milk production curve in New Zealand follows that pasture growth curve. So in June, July, very little. This is for the milk production for the last 4 seasons, the different colours marking the seasons, 2017-18 right through to 2020-21. So very little produced in June, July, and the cows start calving over a 6 to an 8 week period, so increasing in August, and then reaching up in September to a maximum peak milk production in October, sometime around early October. And that peak stays high as long as the pasture growth conditions allow, but starts to drop off as pastures lose some quality and start not growing as fast through late November, December into January, and of course February, March dropping away. And the cows are generally dried off through into late April, May, depending on how the pasture conditions are. So the majority of herds calve in late winter, early spring, which down in New Zealand here is July to September. Milk for 270 days. The dry off in the autumn, which is April to May. They're almost always milked twice a day, although 10% of the herds, and this is growing, have moved to once a day, simply as a labour-saving device. And sometimes as pasture growth declines, in other words, there's less pasture for what the cows require, then farmers may change from twice a day to once a day milking from Christmas, January through to dry off period in April. So now to the structure of the New Zealand dairy industry. It is cooperative structure. The features of this are farmers are linked to processors. Fonterra is the major cooperative cooperative company in New Zealand, and all of the farmers who supply milk Fonterra are shareholders. It processes 80% of the milk, and it markets that milk as well for those farmers. Fonterra is also heavily involved with support industries, extension, training, animal genetics, artificial insemination, AI, and also data recording. So there's a cooperative structure where farmers are linked to processors, and then there is support industries. The next slide perhaps puts it in diagrammatic form. So we have the Fonterra group. We have 11,000 farmers. They're producing 21 billions of milk. Fonterra sends milk tankers to each individual farm to collect that milk, returns to the factory, is produced products, and go out as brands. And you would have seen Indonesia brands such as Angkor Butter, Mainland Cheese. Then we have service companies such as Livestock Improvement Corporation, which I'm going to mention what they do in a minute. We have Dairy NZ, which I'll mention what they do. And then we have Marketing and Innovation Group within Fonterra. So Livestock Improvement Corporation is a cooperative structure. The farmers purchase goods from LIC, or Livestock Improvement Corporation, and therefore they become shareholders based on the amount that they purchase. So what Livestock Improvement Corporation does, it herd tests, records milk, and analyses that milk and returns it back to the farmers. It runs a bull breeding and sire proving service, and then feeds that back to farmers through selling semen and providing AI services to inseminate the cows on farms. It also collects industry statistics and has farm consultants. And so here we have three pictures here. The first one is a farmer working on a computer. We're doing animal recording or feed budgeting. Here we have a young woman with bagging some young calves, which will be going into the animal recording or minder system. And here we have a person collecting milk at herd testing in the shed and collecting that test to test for milk, for solids and other material. The Dairy NZ is a service company, and that's paid for by levy on farmers' produced production. In other words, every kilogram of milk solid produced, 3.6 cents are deducted to go back to Dairy NZ to do these things: on-farm research and development, extension and education, farmers and others. They have some research farms where they carry out research into dairy production, and they have a whole system of consulting officers or extension officers who assist farmers on day-to-day management and planning. And that's all funded through a levy system, which every farmer that supplies milk is levied at 3.6 cents per kilogram of milk solid. Fonterra has a strong marketing and innovation system. So it's always trying to produce and develop new products for milk, developing functional foods, things like low-fat milk, high-calcium milk, high-protein milk, biomedical and health products, and hyperimmune milk products. And I've just put some pictures here. So here we have the Young Yum milk brand, which is mainly marketed in China. So this is fortified milk for the young student. This is fortified milk for adults. We have calcium plus milk here. We have a Yakult, a sort of a vitamin type drink here. Now, of course, I guess today this is hardly a functional or a healthy product, ice cream, but it's certainly a well-being food, I think, in today's COVID climate. So just some opportunities for New Zealand farmers and things that are front of mind for our farmers right now. Every one of our farmers is grappling with these issues: water quality, groundwater runoff, and there is limits on how much fertilizer nitrogen can be used, and then an attempt to try and prevent that end running off into our waterways and perhaps polluting fisheries and causing growth in our waterways and perhaps downgrading our water supplies. They're active in trying to reduce methane emissions, and they have an agenda where they hope by 2030 to reduce greenhouse gas methane emissions by 13%. Animal welfare is very, very high on the agenda of all our farmers, and right from birth right through the entire life. We in New Zealand have Welfare Act, and so it's an act of Parliament, and we have codes of welfare for all livestock practices. So that's very important, and it's almost a social license coming in for our farmers to farm dairy cows. There are some other challenges and perhaps opportunities for our dairy industry. It's evolved considerably, as you saw from the size of the herds and the production per hectare over the last 100 years, and it's going to evolve. It's evolving every year. There is conflicts between our high-producing farms and meeting environmental standards, and farmers are going to have to adjust to that. I already mentioned fertiliser. They have to fence off waterways so that the cows have no access to waterways. And consumers of our products offshore and the public within New Zealand are scrutinising animal welfare standards, and also consumers and the New Zealand public also want to know how and where their food is produced, and it's produced in an environmental and animal friendly manner. So the strengths of the dairy industry is really the cooperative structure linking our farmers to the processor and the support entities that support those farmers. They're all linked together into an integrated supply chain. The other thing I think, which is fairly important, I think, when you think of industries in different countries, is that the farmers and the LIC have selected cows that are suited to the New Zealand pasture conditions. So they haven't just imported animals in, they've decided on the crossbred of the Holstein Friesian and the Jersey and come up with this Kiwi cow, the Holstein Friesian Jersey cross, and that is suited to our pasture conditions at the stocking rates that we run. Other countries have similar systems, such as Ireland, but it certainly has worked for New Zealand. So how do I see that as opportunities for perhaps Indonesian dairy industry? And I know some of this has happened in small instances, certainly on Java, but I'm not saying New Zealand is a blueprint, but there are some ideas here that go forward for an integrated dairy supply chain. I might just add an integrated beef supply chain as well. If we're talking about lamb toro beef, and it was very good to see the previous speaker talking about lamb integrated supply chain all the way through to the market. So what we're trying to do is we need to link dairy farmers along the value chain. We do need the right animals for the system, whether they be genetics, breeding, artificial insemination, and we need a mechanism. You know, the smallholder farmer cannot do any of that. It has to be organised for them, and the artificial insemination is delivered to them from a proven bull that is going to produce milk under their system. Indonesia's got a lot of expertise in history of cooperatives, so this shouldn't be foreign to a lot of your farmers. I see some challenges to the dairy industry developing further in Indonesia. The spread out nature, although that may not be a problem if you're supplying the local market. There's a lack of integrated cool chain to move product from farm to factory. That's certainly the case in beef, and so there needs to be some thought about how that can be developed. Perhaps you have such a big local market, so exclusively supplying the local market may not be a problem. It's probably an opportunity. It's an advantage, but perhaps the biggest barrier perhaps to developing a bigger dairy industry is the low consumption of milk products by Indonesians, and so products need to be developed that the Indonesian consumer like and will consume. So that's the end of my talk. Thank you.
Thank you very much, Professor Stephen Morris, for your great presentation. Ladies and gentlemen, now we will have next speakers, which is Professor Dennis Poppy from the University of Queensland, Australia. The title of the presentation is Moving into More Profitable Beef Production System. Allow me to read the curriculum vitae of Professor Dennis Poppy. Professor Dennis Poppy is the PhD graduate from University of Queensland and currently is a professor at the School of Agriculture and Food Science and at the School of Veterinary Science, University of Queensland. Besides that, Professor Dennis Poppy is also an adjunct professor at the Faculty of Animal Science, University of Mataram. Professor Dennis Poppy is a big beef expert in cattle production system, the application of and modification of nutritional models, and also an expert in crop livestock system in developing countries. During his tenure, Professor Dennis Poppy produced hundreds of journal articles, book chapters, and conference proceeding papers. Now, I will invite Professor Dennis Poppy to present his presentation. Please, the time is yours.
Thank you, Yusuf. Selamat pagi. Let me see if I can get my screen working properly. Now, is that, sorry, is that working?
Can you slideshow, Dennis?
Yes, I'm just trying to, changed on me. 5% view. Sorry about this.
Please share the presentation at the bottom of your monitor, I see.
Yes, I'm looking, sorry.
Yes, exactly. Click.
Yep.
Not yet. Maybe you lead back to.
Let me just start it.
Start it again, yeah.
Start it again,
Yep.
and okay. Now share screen. And where are we? I went through this several times yesterday.
Green button at the bottom of your monitor.
Yeah, I've done that, Yusuf. I'm sorry. I had this open. Okay. My apologies. I need to.
Could we ask Bogor to share the screen, Dennis?
Yes. Yeah. Okay. Just wait 1 second. I am just about doing this. Let me just see where I am. And where are we? Oh. My apologies. Right. Is that better? Is that it?
Thank you very much. Dennis,
Okay, thank you very much. So my apologies. So Selamat pagi. Thank you very much to the organisers for inviting me and my co-authors to talk to you about our work with beef production systems within Indonesia. So I'd like to acknowledge my co-authors in Artin Prianti, Kusmatono, Marsetio Dalanudin, Tanda Panjaitan, Risa Antari, Karen Harper, and Simon Quigley. So the issue that we are facing here is that Indonesia wants to increase beef production, and it wants to help farmers to move into the supply and value chain. So make profitable beef production systems do not always equate to biological performance. As scientists, we're always trying to increase our biological performance in terms of live weight gain, etc. But it's very hard to do this at a higher profit or with lower or acceptable risk to the farmer. Risk is often most important aspect in terms of adoption for farmers. So let's look at some of the current beef situations. This is not exhaustive, but it gives you an indication of the variation. So Deanne in East Java from Grati looked at a number of village systems and achieved or found values of 0.5 kilogram a day with about an income over food cost, daily income over food cost of about 15,000 rupiah. Artin in various surveys found lower live weight gains and lower income over food costs when they looked at a wide range of village and production systems. In Yogyakarta, Erna and Gunawan, working with Ongol cattle, similarly found relatively low live weight gains in that around the 10,000 rupiah per day. And the most profitable systems were the ones in NTB with Tanda Panjaitan and Dalanudin with the 100% Lucina-based systems. All these things in terms of income over food cost really depend on the cost structure that you put in for the feed ingredients. And throughout this talk, we have tried to use the cost structure if farmers were to buy them, but in some cases, farmers can grow their own and there is a cost structure associated with that. So what do we need to do? We need to increase live weight gain, but at a cost that leads to higher income over food costs. So the questions facing us are, what breed type should we use? What combination of ingredients to make a ration that results in a high live weight gain? And what level of feeding should we provide? So to answer some of those questions, we need to understand the biological principles of growth. So how does live weight gain respond to the metabolizable energy intake? How do breeds differ? And what effect does this have on the income over the food cost? So here we've published the live diagram of our live weight gain against the ME intake of different rations. And I think this is one of the first collations of a range of data from across Indonesia and using some Australian data for comparison. The barley cattle showed this response curve, and this was collated by Simon Quigley and his Indonesian colleagues. The dotted line came from the Ongol bulls, largely from Grati, but across other sites in Indonesia as well, for example, Central Sulawesi. And this is the dotted line there overlapping that is from Brahman steers in Australia. And this, the dotted line here, is from Eurocross bulls from University of Brawijaya and NTP BPTP there in Malam. This is a very limited data set, but these other ones have around 60 to 100 data sets involved in them. So what does this tell us? We published the regression equations that are in the paper. Firstly, there's no difference between the Ongol bulls and the Brahman steers in how they use energy. The maximum live weight gains, and these, I know that genetically you can get sometimes higher values than these, but these are achievable maximum live weight gains with high quality diets. So with barley cattle, about 0.65 kilograms a day, Ongolan Brahmins, about 1.1 kilogram a day, and with Euro Cross, about 1.3, 1.4 kilograms a day. The second thing this tells us, if we are to get the high live weight gains, we need to have high levels of intake. That's a basic biological principle. And the increase in the dry matter and ME intake leads to the increase in live weight gain for all breeds, but the effect is probably lowest for the barley bulls. When the live weight gain is about 0.2 to 0.3 kilograms a day, which is what we commonly observe in a village, Ongol, Brahman and barley bulls have a similar ME intake. But at this ME intake, the live weight gain of the Eurocross bulls is greater, and this is what we observe in villages. Artin Prianti showed in villages where Euros versus Ongols that the Euros were always higher in the village-based system. So if we take those equations and then start to look at what we require in terms of feed for gain and the income over food costs for the different breeds, different weight of the animals, so these are live weight gains close to their maximums. So the feed for gain, if we look across from 200 up to 400 for any of the breeds, increases as the live weight of the animal increases. If we look at the feed dry matter required, and these are just because of the way you convert metabolic weight into weight and the weight of the animals. For any particular weight of animal, the actual total amount of feed required is not all that different between the three breed types. Now, if we look at the implication of that for the income over food cost, as we move from 200 kilograms to 400 kilograms, for taking any one particular breed, you can see that the income over food cost is going to decrease. If we take any particular weight and look across at the breeds, the income over the food cost decreases from Euros to Ongols to barley. So there's a general statement we can state is that it is more profitable to feed younger bulls and Euro cross bulls. So let's look at what this means for the income over food cost. Taking an Ongol animal, a 300 kilogram Ongol bull, growing at growth rates of either 0.35, 0.7 or 1.06 kilograms a day. And we look at the effect of changing food intake. So we can create a high quality diet, but if we don't feed it at a high level, we lose the advantage of that high quality diet. So here we have the dry matter intakes that are required to give you the growth rates of 0.35 up to 1.06 kilograms a day. The feed for gain, as we reduce the feed intake to those animals, the amount of feed required per kilogram a day increases quite markedly. As we reduce the feed intake or restrict the food intake, the income over food costs for that animal decreases quite markedly. So restricting food intake markedly increases the feed for gain. Restricting food intake markedly decreases the income over the food cost. The income over the food cost, if you look at these values here when you feed them at high levels, is much higher compared to the current systems. And I'll show that in the next few slides as well. We also want to look at the sensitivity of income over food cost to the sale price of the animal and to the live weight gain that we achieve in that animal by whether we restrict through a restriction in food intake or the feed quality. These are all based for this exercise on a high quality based ration. So firstly, the sale price of the animal increases. The break-even feed cost, that is where the income over food cost is zero, is going to increase, but it doesn't increase all that much. At any particular sale price, the break-even feed cost, that is where income over food cost is zero, increases quite markedly depending upon the growth rate of 0.35, 0.7, or up to 1.06 kilograms a day. That means that the higher the food intake, the higher the higher the food intake, the higher the live weight gain, the higher the income over the food cost. But if you restrict the food intake, you're going to markedly reduce the income over the food cost. So what do we really want? We want to formulate a ration that gives a high live weight gain and a low feed for gain ratio, kilograms of feed dry matter per kilogram of live weight gain. We want to formulate rules or a system to be able to replace ingredients if prices change over time or between sites. That is a least cost ration formulator. We want to have a simple system for formulating the LCRs and or an app-based system that can be used by extension services, NGOs, feed companies, entrepreneurs, village cooperatives, and agri-business groups. So as part of the ACR suite of projects, we have developed a simple LCR system, and we've also developed an app called the Beef Up. I was very interested to see the early videos in yesterday's presentation and today's, where iCard was outlining the Smart Feed AgriNap app that they had developed for in the poultry industry. And you'll see there's a lot of similarities to the app that we have developed for the beef cattle. And I think that this is a very interesting way to go because it engages farmers and it enables extension people and agribusiness people to quickly modify diets. So in any of these LCR-based systems, we need to specify some things about the nutritional quality. For example, the minimum metabolizable energy. In our systems, we've been either using 11 or 11.5 megajoules of ME per kilogram of dry matter. That is not high compared to most commercial feedlot rations, but it does enable more feed ingredients to be available. The higher you can generate the ME content, the better. We've set up a minimum crude protein of 12%, and we've set a minimum NDF of 30% in the final ration because usually we have some long roughage fed with these diets. Now, you can set your own minimum values. These are the ones we recommend. There's upper inclusion levels of some ingredients, and we found through experimentation that cassava and various byproducts needs to be included at no more than 40%. Copra meal and palm kernel cake, anecdotally, we've been told to include maximum levels of 25%. And you need to check final mineral content, particularly the calcium phosphorus ratio, or add a premix or a mineral mix to the system. Here is an output from Sumbawa ration that we've formulated. So here you can see you can put in the various ingredients, and the beauty about this LCR is that it limits the number of ingredients that you could put in to a manageable level. These LCRs and apps are free within Indonesia. There are many commercial ones around in the world. They tend to be more complicated, require more information than we have available to us, and they're expensive, whereas this is a much simpler base system. This was developed with Karen Harper and our Indonesian colleagues in this latest ACR project. You can specify what you want in the ration, minimum and maximums. You can put in the cost, and people might query the costs of some of these, but these are the costs at the time we did the calculation. And at the end of the day, it comes out with the cheapest formulation. So here on a dry matter basis, 35% leukina, fresh leukina, 25% palm kernel extract, and 40% whole cassava tubers was the cheapest ration to give an ME of 13.3, a crude protein of 13.37, an ME of 11.6, and an NDF of 35.6%. So that's an example of the output. This is what the app looks like. It has a simple start option where you can put in what you want in terms of minimum nutrients, or you can select by cattle type. It comes out in in this two-screen basis here with your recipe, with what the level of ME was, what the crude protein was, phosphorus, etc. And it gives the proportions and what you need to mix, what rations you need to mix together, and a price for that particular ration. The app is in very early stages of development. It's a simpler based system, perhaps not as robust as the LCR based system, but it can be used quite easily. So if we look at some of the examples of formulating rations using the LCR system, I won't go through all of these, but looking at, say, East Java, Sumbawa, and Central Sulawesi, you can see that there's a mixture of ones. So, for example, here's one at 40% gaplate, 34% rice bran, 25% palm kernel cake, and 0.8% urea at a cost of 3,142 Indonesian rupiah per kilogram. Or another one, 21% gaplate, 50% rice bran, 25% palm kernel, 3.8% copra meal, at a cost of 3,167 rupiah. And in Sumbawa, 100% lucina or 87% lucina with some cassava tuber, or a lower proportion of lucina and a higher proportion of cassava tuber. In Central Sulawesi, mixture of glycosidia and cassava tuber comes out at a very low cost. Or glycosidia, rice bran, palm kernel cake comes out at a similar, very low cost. So these are examples that there's no one recipe. These recipes vary depending on region and cost of ingredients. Some of the work that Kusumotono and his colleagues, particularly Surya and Denny shown here, were looking at using cassava tubers or cassava peels in formulated rations. And here they've changed the proportion of cassava in a ration with palm kernel cake and copra meal as the other major ingredients, and just showing you the live weight gain. So at 40% cassava inclusion, whole cassava tuber, 1.35 kilograms a day for these Eurocross bulls. The feed for gain, very low. If you've worked with commercial feedlots, this is an absolutely excellent result for the feed for gain. And the feed cost for gain, about 18,000 rupiah per kilogram of live weight gain, that converts into an income over food cost of 42,000 rupiah approximately per bull per day, which is a marked increase over what I have shown you previously occurs in villages at the present moment. Another example of formulating a supplement by the LCR system and looking at it as a supplement to either corn stover or elephant grass to Ongol bulls or barley bulls. And this is the work of Masecho and his team from Palu. So the corn stover or elephant grass with 0.4%, 0.8, 1.2 or 1.6% of body weight as the supplement. And the supplement is a mixture of cassava tuber and glycosidia. The live weight gains increased the higher the level of supplement. The income over food cost increased the higher the level of the supplement for both Ongol bulls and barley bulls. And interestingly, in terms of income over food cost within this system, not much difference between Ongol bulls and barley bulls in their income over food cost. In other words, the daily profit in that particular system. Other work with Ade and Dalo Nuden and the team there in Lombok looked at the use of cassava chips or ongok as supplements to a lucina-based ration. So here we have 100% lucina, and we increase the level of cassava chip or ongok in that system. First thing is that the maximum live weight gain to cassava chip was about 0.65 kilograms a day at 40% inclusion. So a similar result to what Surya and Kusumotono found in Brawijaya. And the maximum live weight gain for ongok was about 0.32 kilograms a day at 25% inclusion. So a lower level. Firstly, the cassava chip, the whole cassava chip, gave a better result than the ongok, and that's largely due to the higher starch inclusion. But it also shows that the ongok these days is a different product to the ongok previously. We've had much better results with ongok in other areas, but as the processing methods have changed, even the commercial feedlotters are downgrading the ongok because there's less starch in that particular byproduct now compared to previous processing methods. So some of the examples of changes in income over food costs by application of these better formulated rations and by feeding them at higher levels. I mentioned Diane's work where she monitored animals in the village or added a supplement, and the live weight gains increased. I should point out this is an excellent village live weight gain value, by the way. But you can see the income over the food costs still increased by that strategy. In East Java, with Surya before, the product, the ration formulation I showed you before that she used, so a total mixed ration being fed to them in a feedlot, village feedlot-based system, 40% cassava, 25% copper, 25% palm kernel cake, gave a live weight gain of 1.35 kilograms a day at, as we showed earlier, about 42,000 rupiah per bull per day. Central Sulawesi, we showed you Masecio's data, but just to highlight the increase in income over food costs for those particular bulls. And in NTB, Ade's work with the Lakina hay and the Lakina hay plus cassava chip showed a large increase in the income over the food costs, but that's tempered a little bit by the fact that the Lakina hay in this situation, in her situation, gave a much lower live weight gain than the feeding fresh Lakina within the village-based system, which is around about 20,000 rupiah per day per bull. Nevertheless, still shows a significant increase in the income over food costs by applying this system. So we can apply these the LCR system to devise a whole new range of rations, but we can also look at what it might mean for formulating new systems of production based either on things like Lakina or other forage type herbaceous legumes, or in total using total byproducts as Surya and Kusmatono showed in East Java. So in Lombok and Sumbawa, Tanda Panjaitan and Dalan have been talking about growing things between the Lakina rows, and one of those possibilities, well, obviously corn is something that people grow now, but is growing cassava, because the cost of a homegrown cassava is quite cheap compared to buying gaplek in the marketplace. And those things can, as we showed earlier, can devise quite profitable fattening systems. So in conclusion, we've established regressions for the different breed types, and they're published in the paper itself, and they provide a basis now for making some decisions about what we should do. A high ME content is needed if we're to get a high live weight gain. So if we're to formulate and change systems around, we have definitely got to get a high ME content ration. But these are available from the byproducts which are currently available within Indonesia. We just need to be able to combine rations in a better format to be able to achieve those high ME content rations. These come at a cost. In some cases, they're quite cheap if we're using homegrown products, but if we're having to buy them, they can be quite costly. So if we use a high cost and a high ME ration, what I hope I've shown you is that we need to feed them at very high levels if we're to capitalize on the advantages of using them, or a very high level of supplementation. I showed you the data from Secio's work in Palu, where they fed up to 1.6% of body weight. But we also recognized at the time that if we could feed them up to 2% of body weight or more, we would get an even better result. But of course, that was difficult to convince farmers to do that because it is a capital outlay that is required. The daily income over food cost is more affected by the cost of the feed and the live weight gain that you achieve than the sale price, within reason. I showed you the sensitivity analysis giving you a range of sale prices that have that have occurred over the last few years in Indonesia. And you can see in that analysis that the cost of that the live weight gain you achieved, in other words, from the amount of feed that you offered them or that they consumed, was, and then the cost of that feed was the biggest thing that affected the income over the food cost. Now, new systems can be devised, and cassava offers a lot of opportunity. When we looked at ways and means of increasing the ME content, it's a very limited number of ingredients that can increase the ME content of our rations. Corn and grain are some of those. Cassava is one. Other byproducts that people like Gunawan have looked at, soybean hulls, etc., are ways and means of doing that. But what I hope I've shown you is that if we have a cost structure associated with those products, then the LCR system enables us to formulate a ration for a region that is specific for that region, but gives you the lowest cost for that particular region. Now, cassava offers a lot of opportunity, and that's one of the reasons we've concentrated on it, because it can be grown easily within Indonesia. The agronomic skills are there to grow cassava. Currently, the products of cassava can be quite high in cost, but if you grow your own, then there's a great opportunity to add value to the cassava that you've grown, because it roughly works out at about 500 rupiah a kilogram to produce. And so as a consequence of that, it's one of the cheaper ingredients that are around. Corn, of course, does the same thing, but in many ways, from a policy point of view, corn should be perhaps fed more to monogastrics than to ruminants. The ACR-LCR enables rapid changes to recipes. So in the past, I and others...
Excuse me, Dennis, you 5 minutes over already?
Okay, this is the last one. So will enable rapid changes to the recipes, and these opportunities for agribusiness and farms to formulate rations with that ACR-LCR and the app, which we all know will lead to a higher income over food costs. Terima kasih, and thank you very much. And we thank ACR for funding the bulk of this work, and the students and staff of many institutions in Indonesia who have collaborated in these studies. Thank you.
Thank you very much, Dennis, for your very great and excellent presentation. As I said, you have 5 minute bonus from the moderator.
Very good.
Thank you very much.
Thank you. I'm sorry about the stuff up at the beginning.
Ladies and gentlemen, our next speaker is Professor Jianlin Han from the Chinese Academy of Agricultural Sciences, China. The title of the presentation is Genomic Resources of Indigenous Chickens Inform the Rapid Improvement of their production efficiency. Please allow me to read the curriculum vitae of Professor Jianlin Han. Professor Jianlin Han holds a PhD degree in ecology from Lanzhou University, Gansu, China. And currently, Professor Jianlin Han is a professor of animal genetics at Institute of Animal Science, China's Academy of Agricultural Science, Beijing, China. Professor Jianlin Han, also a senior scientist at International Livestock Research Institute. The expertise of Professor Jianlin Han is in molecular characterization of animal genetic resources using population genetics and agronomic approaches. He is also an expert in animal husbandry in extreme ecological environments. Professor Jianlin Han produced 57 peer-reviewed publications since 2015. Professor Jianlin Han, please, the time is yours.
Yes, thank you for let me, Sherry.
Is it showing my screen? Okay, yeah, let me start. Hopefully, yes, my screen is shared. It's really my great pleasure to come back to this forum in Indonesia. I was there for 1.5 years from last January, so I know a little bit more about Indonesian livestock production. As what has been introduced, I'm working for both Hillary at the CA SCARS in Beijing. For Hillary, we are doing quite a lot of the genetics and genomics characterization of farm animal genetic resources with the purpose to characterize, quantify, and mapping the phenotypic and neutral and functional diversity of livestock and poultry species, so that we could find the rational way to conserve and also utilize these genetic resources in developing country. My talk is focused on the chickens. You can see the distribution of chicken population in the world, clearly Southeast Asia down to Indonesia is a place where really say the chicken production is very important to produce animal source food in cheaper cost. I think in Indonesia, we all know every day people will eat chicken meat and egg along with rice. Follow the AFL documentation, we can see there is really some more than 1,500 chicken breed or types in the world, which rank obviously the top among the livestock poultry genetic resources. Without any doubt, chicken is really important among livestock. You can see here the column showing the value of chicken meat alone among the livestock and major crop. Chicken meat valued number 5, which is really important, I think. We are running what's called a global chicken genome project with the purpose to sequence, to analysis all the indigenous and traditional breed of chicken across the world. You can see chickens really not only a producer for meat and egg, but we as humans in our society, we also enjoy chickens from different ways of culture down to sport of, let's say, the cockfighting. So far, I think we can argue that over the last probably 200 years of human selection, we are building really a lot of unique genetic resources, which we can recognize all the chickens just to follow the phenotypes or the morphology. You can see, I think we can imagine a chicken, then definitely we can find it in the world somewhere in a corner as what you wanted the chicken to be. There are a lot of different type of chickens already. Indonesia, yes, you can see Indonesia has documented more than 30 indigenous chicken breed already. While there are still a lot of the ayam kampung, the what's so-called undescribed local chickens everywhere in Indonesia. When we talk about the genomics or genetics of any organism, we are dealing with the variation at DNA level. The idea for this global chicken genomic project is to identify how the chicken was domesticated and spread across the world. We know there are 4 jungle fawn species follow this zoological taxonomy. Obviously, the red jungle fawn species could be the ancestor of the domestic chicken. There are 5 subspecies under the red jungle fawn. They are all distributed in South and Southeast Asia, where Indonesia you do have 2-3 subspecies of red jungle fawn, but you have certainly a very unique green jungle fawn in Java, in Bali, in Lombok. This project has been participated by more than 60, 70 countries in the world, including our major partner of LPVT in Indonesia. We have been analysis DNA variation from mitochondrial DNA moving into the whole genome sequences. The first part of our result, I'm showing you the mitochondrial phylogeny. We know the mitochondria is inherited follow a maternal mode, which means that all our mitochondria are coming from our mother line. So for the we generated and collected almost altogether 10,000 chicken mitochondrial sequences. Follow the phylogeny. You can see we can classify all the mitochondria into different clades. These clades are basically present in today domesticated chicken in different frequency. The larger the pie showing says there is a high frequency of that particular mitochondrial sequence. Follow the color. We can see there are only say 6-7 maternal clades or lineage of mitochondria, which basically suggests to say all the domestic chickens are originated from 6 or 7 maternal lines in the past. When we put all our data on a geographic map, you can see there is a strong phylogeographic pattern, which may suggest, say, you follow the mitochondrial data, chicken could have originated from, say, the Southeast Asia, South Asia, and also, more importantly, say, there could be a unique origin of domesticated chicken in Indonesia. This is the mitochondrial data. We know, say, yes, this is a very small molecular providing very limited genetic information. We have been running a large consortium of whole genome sequencing for chicken. We published a paper last year based on 863 chicken at jungle fawn genomes. This is really, I think, what we call the landmark study for chicken domestication and genetic diversity. We covered all our sampling for the 4 species and also the 5 subspecies of red jungle fawn in South, Southeast, and East Asia. You can see, say, yes, with all the new data, we also managed to recover the mitochondrial sequences. This data is matching properly with all previous report of the phylogeographic pattern of mitochondrial DNA in chicken. For the whole genome sequencing data, there is a much clear sort of phylogeny for the 4 species of jungle fawns and also for the 5 subspecies of the red jungle fawn. This is really something unique compared to the mitochondrial data, which sometimes shows a sort of mixed pattern of red jungle fawn and domesticated chicken, or it's hard to separate subspecies of red jungle fawns. Then we built our phylogeny of whole genome sequencing data. This basically clearly shows us the relationship of the all the jungle fawn species And in particular, one of the subspecies of red jungle, the Gallus spandicius, which is close to all the domesticated chicken based on different analyses. These are basically telling us, say, all the domesticated chickens were likely derived from a single subspecies of spandicius. We did further analysis to look at the divergence or the genetic differentiation of the subspecies from chicken, showing something like the genetic divergence between the subspecies that chickens occurred around 9,500 years ago, which may be an indication of time when chicken was domesticated. We did a lot of, say, the genetics admixture between chicken and other red jungle from subspecies. Clearly, the data suggests that yes, there is the integration of other subspecies into domesticated chicken during the way spreading out from the center of domestication to different parts of Southeast Asia. I think I will not go into the detail, but we definitely for the Gallus banqui in Indonesia, which obviously contributed to the Southeast Asian chicken genetic pools. This is sort of the level of genetic integration of different subspecies or species of jungle frogs into today the domesticated chicken population in different parts of the Southeast Asia. You can see Indonesia, the local chickens here, basically they inherited the genetic component from Gallus and also from Gallus banqui, very minor component from green jungle frog. From here, we look at it to say, yes, in the genetic resource or the genetic pools of domesticated chicken today, is there any, say, what is happening, say, in the genome? Is there any sort of the footprint of the genetic load or genetic cost? We know, say, during the domestication, all the species suffered a sort of bottleneck. This may lead to sort of accumulation of, say, the damaging or the harmful mutation in the genome. We published a paper this year based on the data stem or expanded from our early study. We've identified, say, yes, in the chicken genome, there is obviously a pattern of bottleneck leading to the accumulation of high impact mutation. These high impact mutations, mostly they are harmful to the health of chickens today. We did a lot of different type of analysis to validate our observation. Clearly say yes, there was a domestication bottleneck leading to the accumulation of the deleterious mutation. And we also realize, say, yes, people would think, say, yeah, the chicken has been selected into so many different breed or varieties. What is happening? What's the power or the effect of the human selection? Why human selection is not able to clean that sort of harmful mutation? We see that yes, most of that sort of mutation are inherited in a recessive mode. That is how they can hide in the chicken genome. So therefore, I think to conclude my presentation, we see chicken was domesticated from a single red jungle frog species in southwest northern Thailand and Myanmar, in that corner of the world. chicken were translocated from there into different parts of the world. The way they have been hybridized with different subspecies I mentioned earlier. I say yes. Today, in the chicken genome, there are quite many sort of harmful mutations. We need to find a sort of way to strengthen or to go for the sort of the precision genetic selection to clean up the chicken genome so that we are not worried about the inbreeding effect. I think this is a really very important study for chicken based on the whole genome data. There has been quite a lot of the highlight or the public attention on our research. I think at the end I will show you yes, chicken is a really important livestock poultry species. But when I was in Java or visited also Sulawesi, we see for Indonesia, people enjoy chicken not only for the meat or egg, but they enjoy chicken from this cockfighting, the crowing. You will also create the beautiful Pakistan chicken by crossing the chicken with the green jungle. We need basically, I think I visited the farmer of Ayam Pelon. I will see they are really much fun of the chickens for not for productivity, but for culture and for history. We need to recognize that sort of value during our genetic improvement of our chickens. Thank you very much.
Thank you very much, Professor Jianlin Han, for your excellent presentation. Ladies and gentlemen, we are now start our discussion session. For this particular time, I will ask Dr. Madesri Asih to show the question to our speakers. First, I think we will address the question for Dr. Rahmat Hidayat. This question from Dr. Rani Hapsari. The question is, we start with question for Rahmat Hidayat.
Okay.
Bumade. Could you start with the first speaker, Bumade? Yep. Sure. For okay. Oh, maybe we go to the question directly from one is for Professor Jianlin Han.
Yes.
Question is, are internal parasite in problem for rising? For rising Dorper sheep in humid tropical Indonesia. So this is I think question for Dr. Rahmat Hidayat. I'm sorry. And the second is how to increase the productivity of goat farming in Indonesia, that goat farming becomes superior as applied to cattle. Sorry, this is a question for Dr. Rahmat. Please, can you give the clarification?
Okay, thank you. First, from the Prof. Jianlin Han, internal parasite a problem for rising Dorper in humid tropical Indonesia. Dorper has good resistance for endoparasite in Indonesia. It's proved by there is no cases of parasite in Dorper development in the farm. which is ectoparasite and endoparasite. And Dorper have good appetite. They all of the ration which soup, then can all of the part of the grass and eat the dry grass through. And in the case of the parasite, there is not cases. So I can say that the Dorper has a good resistance for the parasite in the humid climate in Indonesia. And second, from Pak Dr. Cuk Imran, to increase the productivity of the sheep, we can shift the concentrate to the ration. We have to make sure that the ration contain all of the nutrients which needed for the animal. So it is not enough to serve the grass only, but we should feed the animal by concentrate too. And the third question is from Ibu Bes Disnamurti. Yes, Bu Bes, the sheep was shown periodically, and for 3 months, periodically the sheep is shown. But the Dorpers molting too, and so the Dorper have the shot of wool. The Dorper is made type of sheep, and so the wool utilized. So I don't know about the wool quality of the Dorper. And the fourth question from Pak Tanda Pajaitan. The main key to avoid pneumonia problem is the housing system. The housing was designed as a cage, and the height of the floor of the cage about 180 centimeters from the floor of the cage. So the pneumonia can be cleared from the cage. There is no pneumonia case because the air of the cage and of the housing is clear from the ammonia pollution. As addition, the outstanding ability is being able to utilize flow quality feed properly with various nature of for feed, resistant to heat stress and resistant to ectoparasite. And in the future, we will develop Indonesian Dorper, but the Dorper prolification is not better than from the local breed sheep as a Garut. So, due to the acceleration population number, we should cross Dorper with local sheep who have good prolification. Thank you.
Much, Dr. Rahmat.
Okay.
Now we continue to the question for second speaker. The question for Professor Stephen Morris. Can we have the slide, share screen? Next slide, please. Okay, please, Professor Stephen Morris, there is a question for you.
Okay, the first question, Anchor is a brand of Fonterra, so it is a private, it doesn't belong to the government. It's a private brand of Fonterra. So that's the answer to that question.
Yep.
Yeah,
Can
the second
go to
one
the second question, please?
From Prof. Dalan. Yeah, that's a big question to answer, but it has to be driven by the commercial or the private sector, and for things to happen. Okay, so farmers need to be collected together and need to have some incentive to supply a particular processing company who has to have access to the market. Now, where the government should come involved is that it should allow for those things to happen seamlessly. Maybe tax incentives, maybe development costs. But it really is the private sector that's going to drive this to allow the industry to thrive and increase. So it is linking everything together. The farmers have to have some incentive to produce milk. There has to be a factory that is able to collect enough milk to make it a profit, and it has to produce products that the consumer wants, and it needs a chain, a cool chain, to be able to produce those products. And then, of course, you've got the cows. Have you got the right cows? Is a big Friesian, Holstein Friesian, capable of 20 or 25 litres of milk? Is that the right cow for a tropical environment where feed is limited and it's cut and carry? I would have thought you would want a more moderate-sized cow that is easier to feed. Okay, does that answers Prof. Dalan's question?
Yes, you can continue. The third question, please.
Yeah, the third question, I believe AgResearch is measuring greenhouse gas emissions, methane, really, from Friesian, Holstein and the Kiwi cross and the Jersey. Our belief is that there won't be much difference, but really methane, or the greenhouse gas methane, is driven by feed intake. Okay, and if you have got a bigger cow and you have got a bigger herbage intake in that cow, then it's going to produce more greenhouse gases. But per kilo of body weight, the greenhouse gas output is probably similar. Okay?
Yes, thank you, Stephen. Can you?
And the last one,
continue?
The crossbred cow is really the industry, farmers, realising that a moderate-sized cow that is better suited to grazing is going to earn them more profit per hectare than a big cow that maybe goes through periods of feed shortage, and so they have to rely on more supplements, which are very, very costly, and so profit margins are eroded. And so farmers soon realised that a moderate-sized cow was the best one for that, rather than a pure Friesian Holstein, which will produce more milk, there's no doubt about that, but at a cost. And it has to be fully fed to be able to realise its potential. And so when you're in a limited feed environment, then you're better to go to that moderate-sized cow that you can feed to appetite. And so it can produce not only milk, but reproduce every year on time and at the right time, calve each year. Okay?
Okay, thank you very much. We have 1 minute. If there is one to ask more clarification from the people that ask. Yeah? Okay, we keep going now to the short speakers. Professor Dennis Poppy, please, you have some question from our audience.
Okay, thank you, Yusuf. The Beef Up app is available in Play Store. It's free to download. We would welcome, it's in the early stages of development. We would welcome any feedback. Karen Harper is the person leading the development of the app, but individuals, people listed as co-authors on the paper, have also been using the app in various ways. It can be used in different ways. So any inquiries, you could go through them, who will go back to Karen if there are issues with that, because we would like to get an app that's going to be user-friendly. So yes, it's available on Play Store. Are the ingredients used limited by variety on purpose, etc.? No, they are not. The app itself has a limit just because of the ability to use the material, but there are options of ways that you can manipulate that limit. So for example, if you don't find your ingredient, you can actually create a new ingredient, or you can just use an old name and put your new ingredient composition in, and that's one way around it. So these are some of the little teething issues, if you like, about application. But you can't make it available to thousands of feed ingredients because it just becomes too difficult to use, etc. So, for example, the tofu waste, etc. That would probably, I think, would still be best and more simply used within the LCR system than the app. But you can use the app in that particular way. You might just have to change the title of the thing, that's all. But it's quite easily done. Which one's more profitable, barley and Ongol managed in the same fattening system? Well, I think we showed that when they're basically managed within village systems and where the live weight gains are relatively low, then there's not much difference in the profit between both barley and Ongol cattle. It's when you start having much more profitable or high quality rations that you are going to feed at higher levels. So for example, at in excess of 2.5% of body weight, that's when the differences start to occur. So you could see in that work I showed you of Marcecchio and the team at Palu that there was no difference between Ongol and barley, even at that 1.6% body weight supplement. But we don't have the data on that particular one, but if you were to increase it up to ad lib of that particular ration, as opposed to acting as a supplement for a lower quality ration, then I think that the Ongols would gradually start to outperform the barley cattle. But it does depend on where you are and the cost of those particular ingredients. And I think that's the advantage of using this LCR system. The LCR system is something which the poultry people use, the pig people use, dairy people use throughout the world. It's not a new concept at all. The only thing that's different here is that we've got a relatively simple one that's free and available and can be used and produces some different rations which you can manipulate when you know the prices in your particular region, or if something becomes quite cheap. So in parts of Java, cassava tips, cassava peels become available for certain periods of the year at very low prices. So you can easily incorporate those using an LCR approach. Can you suggest how to integrate feed ingredients and feedstock to all regions of Indonesia, because every region has specific weather, plant, etc. That's true. And I guess that was one of the main messages that came out of the work and what we presented in the talk. So we've developed recipes in the past, but if you move from Java to Sumbawa or to Palu or to Jogja, do you use the same recipe? Well, for example, we were using gap leg. The price of gap leg varies so much between those different places. The price of copra meal varies so much between those different sites. And so having the composition of the material and the cost structure associated with it, and using the LCR, in some of those slides I showed you can formulate quite different rations. And that's one of the advantages of using that particular approach. So I can't suggest which ones would be in a particular area, but if I went to a particular area, I'd find out what the price of the main ingredients are, including things like tofu waste, and put that into the LCR system and see what sort of a ration it formulates. One problem with the LCR system is you can formulate for metabolizable energy and crude protein, for example, but if there are problems with the level of inclusion, as we showed with the gaplec or the cassava tubers, then you can have something with very high ME and crude protein, but the animal will not eat it or not eat enough of it for them to give a high live weight gain and hence a high income over food costs. So there are this local knowledge. You have to test some of these things first. And that's why we have limits or recommended limits on some of the ingredients. But you will know what other ingredients, what limits there may be on some of those other ingredients. And if you don't know, then that's an area of experimentation that you can use. Thank you.
Thank you very much, Dennis. I think that's all the question that from our participant. Now we move to the question for Professor Jianlin Han. Please, Professor Han.
Yes, I see other questions in the Q&A. I provide some answer already. Here, I think the major or the common understanding is when we are dealing at the moment the genomic preparation, we are trying to understand, say, the orange of diversity, the differentiation of different breeds, say, for example, the young combine across different islands. We are not yet to link the genomic data to the phenotype or productivity at this moment, but as what we heard yesterday regarding the how we can move on for genomic selection with the basis of the reconstruction of a resource population. I commented, with the genomic data, which can help us to identify our, say, unique chicken genetic populations, in Indonesia, to represent most of the diversity of variation at, genomic level or phenotypic level. This is how we could use the genomic information to speed up the genetic improvement of local chickens. Thank you.
Okay. There is no more question. Thank you very much for all our invited speakers that's already delivered their presentation. Now, it's the time for us to give the certificate to our invited speaker. First, there will be presentation of certificate for Dr. Rahmat Hidayat.
Good.
Thank you very much. And the second is the certificate for Professor Stephen Morris.
Terima kasih.
Okay, thank you very much, Professor Morris. The third is the certificate for Professor Dennis Poppy.
Terima kasih.
Thank you very much, Dennis. You are quite welcome. And then the fourth is the certificate for Professor Jianlin Han.
Okay, yes, thank you very much.
Okay, thank you very much, Professor Jianlin Han. Now we give applause to our invited speakers.
Thank you for all.
Thank you very much. I know that there are a lot of question that's not haven't got any answer, and then we will pass the question to the speakers through email, and then we hope that we will have the answer for all. That is the end of the session. Thank you very much.
Thank you.
Thank you
Enjoy
very
your
much.
time.
Thank you.
Thank you, Yusuf.
Thank you.
Thank you very much for speakers for informative and insightful presentation. And thank you for Professor Ahyar Sutaryono for moderating this session. Ladies and gentlemen, now we welcome you to have a 10-minute break. After that, we'll start oral presentation, session 2. Please enjoy the short break time.
Food had and has always been an important issue in the world. All countries try their best to fulfill the need for food. Agriculture plays important role in the national economic development to achieve food security. Indonesian Agency for Agricultural Research and Development, or known as IARD, Ministry of Agriculture, was established in 1974. Until today, IARD has strategic role to improve agriculture efficiency and competitiveness, as well as contributing significant development on agricultural technology through its innovations. IARD is currently supported by 4 research centers based on commodities. They are food crops, estate crops, horticulture, and animal husbandry. IARD is also strengthened by 7 centers of specified research, 14 research institutions and stations, 33 assessment institutes, with total human resource of 1,680 researchers. 138 among them are research professors. IARD provides quality assurance of its research results through an accreditation or certification process to be acknowledged nationally and worldwide. IARD has produced thousands of innovative technologies, from improved varieties, agriculture cultivation system, fertilizers and pesticides, to advanced technologies such as fertilizing drone or smart greenhouse, Around 600 technologies are the superior ones and are expected to be widely used by the community. Indonesia has a great potential to increase agriculture production. IART contributes in determining its strategic food commodities, namely rice, maize, soybean, shallot, garlic, chili, sugar, and beef to be priorities for strategic self-sufficient program through innovative technology. Therefore, the national needs shall be fulfilled. Technology implementation from on-farm to post-harvest guarantees an increase in the quality and quantity of agricultural produce. The challenge to meet food needs is not only for the country, but Indonesia can also support the world. IART will continue to innovate to provide technologies toward Indonesia as the World Food Basket 2045.
Ladies and gentlemen, we are going to have panel session 2, and you can proceed to your presentation room. Please see the program book to know about break room session. The room is divided into 3 rooms as follows. Room 1 is livestock production. Room 2 is livestock nutrition and feed technology. Room 3 is livestock production and livestock nutrition and feed technology. Again, I would like to remind you to turn on your video and mute your audio. We also require you to change your username by adding a room code in front of the name. If you have any difficulties, please ask our committee. Ladies and gentlemen, after oral presentation session 2, we have the closing ceremony, and I would like to invite you again to return the main room. And with honor, I will give the host of the closing ceremony, Dr. Made Sri Asi, as Master of Ceremony. Ladies and gentlemen, the break room is begin.